Hello, students. So let's try list comprehensions. Now, they're not all that different from set comprehensions. Let's start simple. Let's say I want to get the numbers 0 through 5 in a list. What I can do here is I can just say, hey, give me the list, instead of set, give me the list of all x for x in range 6. And this should give me 0, 1, 2, 3, 4, and 5. Now, let's say I wanted 5, 4, 3, 2, 1, 0, right? Because we know that order matters. So one thing I could do here is I could say, okay, give me 5 minus x for x in range 6. So I get 5 minus 0, 5 minus 1. And as you'll see, these are two different lists. And you could even check them if you want, being a little overly paranoid. But you know what? Let's do it. Let's make sure these are not the same. And as you see, they are not the same. So if I converted them to sets, they would be. Okay, so let's try something just a tiny bit more complicated. Let's try the list of x squared, where x is strictly between -5 and 5. So for x in the range, so I want it to be strictly in between -5 and 5. So that means I want it to go from -4 to 5, because that's going to be the closed interval on the left. That's going to give me -4 on the left. I'm going to get a 4 on the right because ranges are open on the right. So let's see what I have here. And I have something, I wouldn't see this if I tried this as a set, but as a list, I can actually see this. Let's see what I get as a set. I get the following: 0, 1, 4, 9, 16. But as a list, I have the order that's associated with taking the numbers from -4 to 4 and squaring them. You can see this, and I can grab any one I want using an index if needed. Okay. Just like with sets, I could have more than one variable in my comprehension. For instance, let's say I want a list of, let's see, I want pairs, A, B, and I'm going to let A be any number. I like 0 through 5, so let's stick with that. Range of 6, or B in range of 6. But I only want B to be a little more than A. So B could be, let's say, 1 or 2 more than A. So how would we do that? Well, one thing we could do is we could say if B is equal to A plus 1, or B is equal to A plus 2. And this would give me this collection. And as you see, B is 1 or 2 more than A in each of our situations. Now, you'll notice that A never got to 5 because I'm restricting our pairs A and B to both be from range 6, which means they have to both be between 0 and 5. So the only way that I could have B be bigger than A is if A is not 5. And if A turns out to be 4, then B only gets this one choice, 5. Python takes care of all of this for us in this list. And you can basically read it. This is going to be the set of pairs AB, where A and B are in the set 0 through 5, so that B is 1 or 2 more. And we don't have to know that A can't be 5, and we don't have to know that when A is 4, we only get 1B in order for Python to do this for us. Python takes care of that. Now, there's a lot of different ways I could do this. Another thing that I could do is I could say, okay, I'm going to, I know I want B to be 1 or 2 more. I could say if B is less than or equal to, or you know what, let's use containment. So what did I do here? Well, we know that, if I check to see if B is in a set, I'm going to get either true or false, because either it is in the set or it isn't in the set, right? That's how in works. So basically, I'm looking at all the possible A's and all the possible B's, and I'm checking to see if B is in the set A plus 1, A plus 2. But really, still, I'm checking a lot of things. Now, of course, there's only a few combinations here. We've got 36 combinations. So this is going to run incredibly fast. So fast that, small changes, we might not even be able to measure them. But let's say we wanted to get even a little bit more efficient. We didn't want to check all 36. Well, if I know that B has to be 1 or 2 more than A, one thing that I could do here is, well, let's try this in two different ways. One intermediate step before I get carried away here is B, I could do this. So now I'm only checking the values of B that are bigger than A. So I'm checking less values. Now, of course, this doesn't make any difference in our output, but it does make a difference in how many cases Python is checking. And if we were going instead of to 6, let's say we were going to 6 trillion, this might make quite a sizable difference. But you know what? Since B is either 1 or 2 more, I think we can do this even better. Let's try doing something like this. Let's let B be 1 or 2, and I'm going to get rid of this entirely. Now, you might say this is going to give us the wrong answer, and you're right. But if I do it like that, I'd get the wrong answer. If I do this, let's see what happens. I'm taking the pairs A plus B, where A is still any of the numbers we want, but B is now in the range 1, 2. Now, there is one issue here. The issue here is that by letting B be in the range 1, 2, I'm now going to get more. First, there's two issues here. One issue is I used the wrong range, right? Because this means B can only be 1. So there, that's what I meant to do. So one issue is that I'm going to get more values, right? Because now A can be 5. B, I'm not capping A plus B here. So one way to fix this is I could say, okay, if A plus B. Now remember, we wanted these numbers to be within this range, right? So this could be at most 5. And now you'll see this gives us the same values that I got here. And like I said, time-wise, this isn't going to make any noticeable difference because we're only going to 6, which is very, very small. But if we were going to a trillion, and sometimes we deal with very, very big numbers in math, this would make a difference. So we've seen some examples of list comprehensions. We've seen that order does matter. We've seen that we can do list comprehensions with more than one variable. There's a lot of things that we can do with list comprehensions, and I guess let's take a look at more things in the next video.